1.6d, day 4, Trig Identities. This is Reflection Lake at Mount Rainier National Park in Washington State. You will be using trig identities throughout the year to solve calculus problems. Today we will look at some of those identities and where they come from. When you need to use a trig identity, you will not have time to generate the identity from scratch. They need to be memorized. The easiest trig identity is the Pythagorean identity. The coordinate of this point is cosine theta sine theta. Since the hypotenuse of this triangle has a length of 1, we can just use the Pythagorean theorem. Sine squared theta plus cosine squared theta equals 1. Consider angles U and V in standard position on the unit circle, determining points A and B and their coordinates. There's angle U. So the coordinates of A would be cosine U, sine U. And an angle V, and the coordinates of B would be cosine V, sine V. We could find the length of the chord AB by using the distance formula. AB equals the square root of cosine V minus cosine U squared plus sine V minus sine U squared. Let the difference between the angles be theta equals U minus V. We could rotate the angle AOB around to standard position without changing the length of chord AB. We rewrite the coordinates of A and B in terms of theta. So the coordinate of B is 1, 0. And the coordinate of A is now cosine theta sine theta. Using the distance formula again, we have AB equals radical cosine theta minus 1 squared plus sine theta minus 0 squared. But since we rotated this angle, the length of the chords are the same, so we can set the two expressions equal to each other. So there we have the two expressions set equal to each other. I can square both sides to eliminate the radical sign. Then I expand. Now, I see some things I can simplify. I have cosine squared V plus sine squared V. We know that's 1. And there's another cosine squared plus sine squared. This time it's cosine squared U plus sine squared U. And on the right-hand side, I have cosine squared theta plus sine squared theta. Each of those is a Pythagorean identity, so we can simplify. Now we have 1 minus 2 cosine U cosine V plus 1 minus 2 sine U sine V equals 1 minus 2 cosine theta plus 1. Collecting like terms, we have 2 minus 2 cosine U cosine V minus 2 sine U sine V equals 2 minus 2 cosine theta. Since 2 is a factor of every term, we can divide out of 2, and we get 1 minus cosine u cosine v minus sine u sine v equals 1 minus cosine theta. Subtracting 1 from both sides, we get negative cosine u cosine v minus sine u sine v equals negative cosine theta. We reverse the order and multiply through by negative 1. So cosine theta equals cosine u cosine v plus sine u sine v. But theta equals u minus v. So we get our final identity. Cosine u minus v equals cosine u cosine v plus sine u sine v. So we start with our new identity, cosine u minus v equals cosine u cosine v plus sine u sine v. And starting with this formula, we can find a similar identity. We can rewrite cosine u plus v as cosine u minus a negative v and use our formula. So we have cosine u plus v equals cosine u cosine negative v plus sine u sine negative v. But cosine is an even function, so the negative sign will drop out, and sine is an odd function, so we can move the negative sign to the outside. So we have cosine u plus v equals cosine u cosine v minus sine u sine v. For convenience, we combine the two formulas like this. Cosine u plus or minus v equals cosine u times cosine v minus plus sine u times sine v. These symbols must be written correctly. What this means is when there's a plus sign on the left, there's a minus sign on the right, and when there's a minus sign on the left, there's a plus sign on the right. The cofunction identities are simple to find from the triangle. For example, if we have theta in one corner, the other corner is pi over 2 minus theta. Sine theta equals opposite over hypotenuse, or y over z. So cosine pi over 2 minus theta equals adjacent over hypotenuse, or y over z. Therefore, sine theta equals cosine pi over 2 minus theta. The cofunction identities are not actually included on the calculus quizzes, but they are useful. Starting with this identity, we can substitute in u plus v for theta and get sine u plus v equals cosine pi over 2 minus u plus v, which is sine u plus v equals cosine pi over 2 minus u minus v. But using our earlier identity, cosine u minus v equals cosine u cosine v plus sine u sine v, we can rewrite this part of our expression as sine u plus v equals cosine pi over 2 minus u times cosine v plus sine pi over 2 minus u times sine v. And we use our cofunction identities again to get sine u plus v equals sine u times cosine v plus cosine u times sine v. Using the properties of odd and even functions, we can write our identity like this. Sine u plus or minus v equals sine u times cosine v plus or minus cosine u times sine v. There are 16 trig identities on the calculus formula sheets. Starting with the formulas in this lecture, you should be able to derive the others for practice or for fun. These formulas are sometimes difficult to remember, so if you haven't already, you should make flashcards and get started memorizing.